All right, we are rolling. First, prepare, notes out, gentlemen. First question, Jack Lau, what is the volume for a disk?
IR squared H.
IR squared H, correct. How come? Where'd that come from?
We need the radius, like,
I mean, what formula is that?
oh,
From
it's the
geometry?
volume of the cylinder.
Right, the volume of a cylinder. What is the volume of a shell? T.
2 pi r h
2 pi r h t. What does T stand for? Brother, reminder, there's no food in my room. Just saying.
T stands for thickness.
Thickness. T stands for thickness of the, like the tin can. From yesterday, look in your notes if you must. Can someone please tell me the formula for arc length? It's an integral. It's an integral of what? Yeah,
The integral from A to B of
okay.
the square root of 1 plus f prime x squared
Yeah, the
dx.
derivative squared with the dx at the end. By the way, there's another, you could also replace all of those with y's. You could have 1 plus f of y derivative squared dy, bless you, if it happens to be a sideways parabola or whatever function. Everybody okay with that so far? Again, a reminder, arc length is very, very unlikely to give you a nice answer. We usually use a calculator and round it to 4 decimal places. On rare occasions, I will say, give me an exact answer, which might happen tomorrow. For now, these are the 3 things we've hit so far. Today, I want to cover how you do strange rotations with shells. Quick example. Let's see, we have f of x is equal to radical x minus 3. And I'd like to range that just from 4 to, let me see, 7. Try to write that down. Let me see, g of x is equal to, hang on. Got it. My pen. Hang on, fluffer numbers. Hang on. Gotta make sure I get this right. Oh, I'm just gonna write it as a line. So, y minus 2 equals 1/2 parentheses x minus 7. This will be region A, is between these. Interesting about it. I would like to rotate region A about the y-axis and find the volume. Go ahead and write that down. Once you get that written down, I want to see how, like, if I just plop this at you in front of you as a homework problem, tell me how you do it. Like, where do you even start? graph it, be a good idea. There are only two functions to graph. So, can somebody help me graph f of x equals radical x minus 3? What's another name for f of x, by the way? Y. Go ahead, help me out. Pete?
So it's just like, so radical x is like,
It's
The
plain,
half.
it's like radical x, what's different?
it's, down, no, it's left 3 spaces,
Almost.
right?
Yeah, how come it's right?
Because it always does the opposite.
Input does the opposite of what you expect. So the whole graph moved 3 spaces to the right. Okay, then what's the pattern for a radical graph?
It's over 1 up 1,
Over 1 up 1,
and then over 4 up 2.
over 4 up 2, correct. And we're just gonna go here. It's gonna keep going there. Can somebody graph the other one for me? Polly, help me out. How do you graph this thing? What shape is it?
A line.
It's a line. What form is that?
Slope intercept one.
Slope intercept is y equals mx plus b.
Oh, right,
Close. One of the words was right. The form looks like this.
point slope
Point slope, correct. So where's the starting point?
at 2,
So what comma what?
0, 2.
That would be if it was slope intercept form.
Oh, 7,
7 comma 2, don't whisper. Does that make sense? John, take over. How do you graph that?
So start at 7 comma 2,
Okay,
and then you would go up 1 over 2.
up 1 over 2,
Or-
correct. And if the graph is uncooperative, what could you do?
You could go back 1, down 2.
Yeah.
Yeah.
The down 1, back 2, and if you want to do it again, back 1, down 2. You might notice they intersect at 2 relatively nice points. Does everybody see that the region we want is this? It's an irregular region. And they want to rotate it about the y-axis. This is very similar to a problem you have on the worksheet, I think number 5.
We always have to rotate over the x-axis on the worksheet.
Oh, well, it's same difference. They have a sideways parabola. Why do I keep saying parabola? They have a sideways function. So I'll even give you a little bit of a hint there.
Sorry, my brain's not working well. How did you graph the, radical x minus 3 again?
Oh, radical x, like plain old y equals radical x, looks like, start at 0, 0, over 1, up 1. Like if you did a chart, 0 would give you 0, 1 would give you 1, 2 would give you garbage, radical 2, 4 would give you a nice number 2. So we used over 1, up 1, and then over 4, up 2. That's the normal one. And the only difference is they have a minus 3 in the input. Minus means move, and the input always does the opposite of what you expect. I expected that to go through to the left, it actually went through to the right. This thing, here's -3, -4, -7. You're gonna have phantom, I'm gonna do open dots here, even though they're not really open. And here is the phantom other side. Does everybody have kind of a visual of what's gonna happen here? When you spin this, it'll look like this. It's gonna look like a funnel, like a curved funnel going in. Now, there is gonna be some thickness, it's gonna be a weird funnel with kind of like lumpy plastic. So this is going to be solid. And this is gonna be solid. So if you took this funnel and just cut it with a knife and looked at the edge, it would look like this. It'd be razor sharp here and here, and would be kind of thick here. I wanna know the volume of the thing. There is no standard way to get the volume of this, but there is a trick to it. And it is. Could somebody get me the volume of this if you spun it around the y-axis? Ever look this way? People are not tuning in. Spin this around the y-axis. Would that be possible to get the volume?
Yeah,
How? What method?
shells,
Shells. Why not discs?
because discs gets that inner region.
Yeah, if you try a disc, it'll give you the inner region, that sort of upside down Hershey's Kiss thing. Shells would work pretty well.
So I'm confused because it says from 4, 7, but we're doing it from 3 to 7.
Oh heavens, sorry,
Okay.
from 3 to 7. That was my fault. Thank you. That's a good. Yeah, can somebody fix that, please? The intervals from 3 to 7, not 4 to 7. I would not like to move people. Don't make me. If you want to take this regular, solid radical region, shells look like they're pretty good. If you drop shells down, you can have a whole bunch of tin cans that capture the outer part. Take a look here. This would have been a regular radical region like that. This would have been a regular radical region like that. But what happened? How is this different from this? I mean, they moved it over, yeah. But there's something else, yeah.
We have to subtract a little portion that the line creates underneath it.
You see this sort of, kind of looks like a football stadium. Edgewise, there's all the stadium seats going up, 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 up. And then on the other side, it's like one big donut with seats going up and with half of it shaved off. If you take this volume and subtract the triangle volume, you get your answer. Does that make sense? In other words, you're not gonna do one integral, you're gonna do two, and you're gonna subtract. So basically, you take the integral of the, this is gonna look really stupid. The integral of this thing rotated minus the integral of this thing rotated. Does that make some sense, kind of visually? If you take the entire big chunk, it looks kind of like a bun cake, and then you subtract this sort of football stadium thing from underneath it, you're just gonna have this thing hovering in midair, and that'll be your answer. Let's do this. Can somebody set up the shells, and grab a calculator, you'll need them in about 3 minutes. Where do I need? I'll just try and write small over here. Can somebody give me the shell volume for this thing? What's the volume of a shell again? Julie Sushant. 2 pi r ht. In this particular case, 2 pi, what's r?
dy or dx.
It's big. It's either x, y, dx, or dy. Let me give you a quick example. If you have a cylinder pointing in this direction, here's the radius. Is that in the x direction or y? X. Is it a very small, thin one, or is it a reasonably sized one?
It's big.
Yeah, so what would you call it? X or dx? It's x, right. In this case, the x is there. Max, take over. What is, it's 2 pi r ht. What would you put for h in this case?
Y.
Y. Y or dy?
Why?
Why, how come?
Cause it's not super, super small.
Right, it's not super small. While you're at it, what's the thickness?
Dx,
Dx, good. Why not x?
cause it's really small,
Right, why not y? Why not dy, I mean?
cause it's an x, right?
Right, the thickness is in the x direction. So here is going to be 2 pi x y dx. Ever read so far? Focusing on this, not on extraneous things. Do me a favor. Put x1 here and y1 here. Because I want to tell, there's going to be two different integrals going on here. So I'm going to have this as y1, and this is y2. So you can just tell them apart. Minus the integral of, again, the shells for this triangular thing are identical. 2 pi r h t. It's going to be x, y, dx. The shells are going the same direction. Does everybody see that? If you've got shells going like this, and you've got the triangular thing going, it'll give you the same orientation of shells. The radius is still going in the x direction, the height is still going in the y direction, the thickness is still the dx direction. Does that make sense? Yeah, question.
I'm missing this, that's why I'm a little confused, but how did she know that she wanted the shell? Not,
Oh.
like what portion you're looking at?
Yeah, now, when you know what I mean when I say shell, it's kind of like a tin can with the top and bottom cut off. So it's a hollow shell. If I take like shell and then another shell nested in, and then just nest all of these inside the other, and keep making them shorter, 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 eventually you're gonna have a whole bunch of metal that forms this region I want. If I try discs, the disc goes this way, and another disc would be up here. It would fill up the wrong spot. It would fill up this upside down Hershey's Kiss thing. It would fill up the inside. The outside, we'd have to go shell, 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 shell. That fills up the lower part.
Okay, got it.
Okay.
Thank you.
Here, no problem. I want to call this x2, y2. In other words, just, this is the first one, this is the first function, and this is the second function. This is with x1 and y1, this is x2 and y2. Can somebody fill in, just leave this as x, you don't really need anything exotic. But can I do the integral right now? The other one. Could I do this integral right now?
No,
There's one thing wrong. Yeah, actually there's two things wrong,
the
but.
one,
Yeah, the y, what should it be?
radical x minus 3.
Exactly. I want to replace it with something with x's. So it's going to be integral of 2 pi x radical x minus 3 dx. Are we clear on that? Write that down. Minus what? The integral of, John, take over. What would you, this thing needs to be replaced. Now there's a catch. I want to know what y2 actually is. There's one little step you have to do first.
Add 2.
Yeah, I need to find out y2 by itself. That's an extra thing that the algebra forgot to do for us. If you add 2 to both sides, you should be fine. So tell me what I have so far. Oh, hi, folks.
Mr. Coughlin, you know what
Good morning.
always helps math proceed more easily for me?
Which one? Who?
You know what always helped math go easier for me?
Having the foggiest.
Chocolate eggs. Would your students like chocolate eggs to help math go more easy?
Before or after?
It's your decision, it's your classroom.
Okay. By all means, but save it till after.
I'll just leave them here so they're out of temptations range.
Thanks, Robert.
You're welcome.
Happy
Happy Easter.
Father's
Happy Easter. All right. It'll still be there. Trust me, I will not eat them because I don't want to go to the hospital. So, this thing. Pete, take over. The 2 pi and the x are fine.
So you get 2 pi x, and then you get 1
put that in parentheses, I should have put this in parentheses. And then what's at the end? Correct. What's the interval from what to what, Jack?
It's from,
Are we doing X's or Y's?
we're doing X's.
X's, so from what to what?
3 to 7.
3 to 7. Otherwise, we would have had to go from 0 to 2. From 3 to 7 in both cases. Good. Grab your calculators. Be careful here. A lot of people look at this and they say, oh, I can just do the 2 times a half and cancel. Well, the half distributes. You multiply and do the parentheses first. I would just leave it. I would just say, be careful where you put your parentheses, but type that in exactly as you see it. This is going to be a long formula. Tell me what to type. Like, I'll write it in the old code. If you have a newfangled calculator, you can just put those wherever you need. But let's pretend you have an FNINT. What's the first thing you have to type in?
Are we taking the 2 pi's out in front?
You can. Oh, by the way, that's an excellent idea. Do you notice that there's 2 pi pulled out in front for every single one of them? Does it make sense? Everybody look up here. It's an easy step, but it's easy to miss. Do you notice both of these have 2 pi's? Let me just rewrite that. So 2 pi times this integral minus 2 pi times this integral. This is a common factor. I would just pull the 2 pi out in front and do the integral minus, what am I doing? So a few parentheses. I would do that. Save the 2 pi for the end. At least save the pi for the end. Does anyone remember why? Why not just leave the pi in there?
Pi is irrational, so it makes them messy.
Right.
So you can
The
get
pi
that.
is irrational. It will not give you an exact answer. So you can even throw the 2 back in if you want. It's up to you. But I want the pi to stay out until the bitter end. So if you can type in, it's basically going to look like this. It's going to be 2 pi, and then big parentheses. It'll be the integral from 3 to 7 of x radical x minus 3 dx minus integral from 3 to 7 of x times 1/2 parentheses x minus 7 paren plus 2 paren dx. Do that. The biggest nemesis here is typos. So be careful how you type this in. The first one is FNINT, so leave the 2 pi off. It's going to be x radical, little parentheses, x minus 3. If you have a newfangled calculator, you don't have to worry about this one. Comma, x, comma, 3, comma, 7. That'll be your first integral. Then don't hit enter. Minus another FNINT. This is going to be a little trickier. It's going to be x, bless you, new parentheses. I'm going to do 0.5 for 1/2. New parentheses again, x minus 7, close one set of parentheses, plus 2, close another set of parentheses, comma x, comma 3, comma 7. Try that. I gotta catch up. Hang on a second. So math 9. So x radical x minus 3, comma x, comma. Everybody knows what the comma key is, right? 3, comma. It's a separate key. And then minus another FNIT. X, new parentheses 0.5, new parentheses x minus 7, close parentheses plus 2, close parentheses, comma x, comma 3, comma 7, close parentheses, hit enter, wait 5 years, and I'm curious. Deb, what did you get? Yeah.
I got, well, 6.1333, that's like 92/15.
Yeah, hang on a second. Oh, Excuse me, I just caught a typo. Do you remember how to call back your previous answer, your previous typing? How do you do that?
Second answer?
Second enter, which is totally useful here when you have like 5 billion characters you just typed. So you just up and down, so x, radical x minus 3. Comma x, comma 3 times 7. Okay, minus 7, 9, 2.
What'd you get, John?
6.1233.
Ah ha ha ha. I had -5 instead of 0.5. Wait a billion years and... So you got 6.13 blah 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 blah? Yeah, I did too. So you get kind of sort of this. 6.133333556. Okay, math people, let's see who remembers this from about 3 weeks ago. Hit convert to fraction. It does not want to convert to fraction. Yeah.
So you like type in 6.1, like in like 15 threes.
The 556 is calculator error. This is 6.13 repeating. So if you want to fool the calculator into doing this repeating, exactly, 6.13, and if you type in at least 13 zeros, 13, what am I saying? 13 threes. So in other words, I'd like 13 or more. That will fool the calculator into thinking it goes forever. Try it. On your home screen, do 6.1 and then type in 13 threes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hit enter and convert to fraction. Did it do it? What do you get?
92 fifteenths.
92 over 15. Congratulations. That's this. 92 over 15. Are we done? What do we have to multiply it by?
Okay.
By what? By 2 pi. My suggestion, multiply by 2 first. Well, you can do 2 pi if you want. What's 92 times 2? 184. Give me the final answer. 184 pi over 15. Use your hard-won answer. Does that make sense? That's how you do it. If you have a weird shape that's floating in the middle of nowhere, you may have to do a subtraction problem. And if you can visualize the big region minus the small region, you can visualize the 2 integrals you have to subtract. Question?
This is just a quick reminder, say that it was from 4 to 7.
Yes.
4 and 4, 7, how would you do that again?
Oh, it would be the exact same thing, only you just go from 4 to 7.
Oh, okay.
Yeah, you just lop this off. You would run the integral from here to here for the bundt cake, and here to here for the, and it would work the exact same way.
Okay, perfect.
Yeah, so it's actually pretty easy to do that. I just wanted it to be perfect, because I'm picky. Questions? Take out your worksheet, please, and look at number 5, on 6C-3. There are 2 ways you can do this problem. This is a sideways problem, kind of, sort of. Actually, both of them are, 5 and 6. They're rotating around the x-axis, but they flipped things so that the function is an inverse function. The floor, you have to tilt your head 90 degrees to the right in order to see it properly, or rotate your paper 90 degrees. So it would not look like this. There are 2 ways to do this problem. Is everybody okay with this part? Okay. Actually, I'm going to leave that answer there for a second. I'm just going to do a quick sketch of what you're looking at on number 5. Let me call this up real fast. You should have a parabola that's going sideways. X equals negative y squared plus 4 should go like this. Does that make sense? It's a lot like y equals negative x squared plus 4. It's raised up 4 spaces and then falls down. Over 1, down 1, over 2, down 4, and so on. And then the other graph is x equals y plus 2. This is actually, it's a good mental exercise to try and graph this as it is. You step into an alternate universe where this is an alternate slope-intercept form. The slope is run over rise. And this is the x-intercept. It's kind of fun, but okay, if you absolutely just said, I can't deal with this, I'm sorry, then just subtract 2 and you get y equals x minus 2, which is fine. Y equals, so it looks like this. What they want is the region that's trapped between this, and the line x, I think it's y equals 0. Yeah, and y equals 1. They're looking for this region, spinning around the x-axis. How do you do that? That's a weird sort of piecemeal region. I'll tell you this much. If you spin this region and subtract this region, spun, you'll get the answer. Can we visually see what I'm talking about? In other words, I'm going to do the dotted. Picture if you had taken this entire bottom thing and spun it. You could use discs. It would be relatively easy. They want you to use shells, which is not too bad. Let's just say you take a shell here. It falls to the floor. Just remember the floor is the other direction from what you expect. It looks like this. So it's falling to the floor, then another shell falling to the floor, falling to the floor, falling to the floor. Can somebody tell me the volume of this shell? What's the volume of a shell in general again? Max.
2 pi r ht.
2 pi r ht. In this case, fill in that stuff. 2 pi something something something. R h t. What does R stand for? You tilt your head like this. Yeah. Is it x or y?
That's y.
It's y. What's the height?
X.
That's x. What's the thickness?
dy.
It's dy. Exactly. Can I integrate this as is? I do this, Sean. Why not?
Because of the x.
Yeah, the x is the oddball here. Is there a way to fix that? Now, by the way, this function is x equals negative y squared plus 4.
For negative y squared plus 4.
Right. You use this in place of x. That'll get you the entire region spun. Then what you have to do is do this region spun as a separate integral and subtract it away. Does that make sense? This one is going to be the integral of 2 pi y and then negative y squared plus 4 dy minus another integral. And that's all I'm going to tell you. Use what we have up there to extrapolate what this will be. It's not hard. It's basically take this thing, think of it, the shells will look like this. Like here's the phantom part. It'll send a shell down like that. Look where the radius is, look where the height is, look where the thickness is. And just make sure you know what to, you'll have an x in there. Just replace the x with whatever caused the straight line. In other words, that. Questions? The rest of the hour is yours. Polish off number 5 and number 6 for tomorrow. And we'll see what happens. So Michael, God bless your recovery. I'll talk to you later.